Okay, so we are looking for how many moles are in 65 grams of water. So we are looking for N, because that is the number of moles. We are told the mass is 65 grams, and we are told the material is water, H2O. Okay, so that's going to be 1.01 times 2 plus 16 for 18.02 grams per mole. Okay, so you get 1 mark for that. Okay, we're looking for the number of moles, so N equals little m over big M. So that'll be 65 grams, the mass, divided by 18.02 grams per mole. All right, the grams will cancel, and we'll be left with moles. So 65 divided by 18.02 gives us 3.61 moles. Okay, so 1 mark for that and 1 mark for your work. Okay, 3 mark question. Ethan, question? Yes. Yeah. Okay. That way, like especially when you're manipulating, I'll know if you had a trouble with the algebra. Here, I would know whether you just accidentally mixed 2 things up. I would look back at your givens and go, oh, okay, they've got molar mass and mass mixed up. It helps me to diagnose where the problems are for you. Okay. All right, how many people have done question 2? All right, let's look at 2 as well then. Okay, so we are looking for the mass of 8 moles of magnesium chloride. So they told us we're looking for mass. Okay, they told us that it's 8 moles, so N is 8. And we're looking for magnesium chloride. Okay, so we got 24.31. Sorry, I should write out the formula first. Bad habit there. Okay, so magnesium with chlorine, this is a -1, this is a +2. So we got MgCl2. So that'll be 24.31 plus 35.45 times 2. Okay, so 95.21 grams per mole is our molar mass. Okay, so 1 mark there. Okay, we know the mole equation is going to be in place here, so little m over big M, but now we're trying to solve for little m, which means we have to multiply both sides by big M in order to move it. Okay, so we would get a mark for that manipulation, and that would mean that mass will equal our 95.21 multiplied by 8 moles. Okay, so you'd get a mark for plugging in the numbers. Okay, so we're looking at 761.68 grams as our answer there. Questions on number 2? All right, how many people are done number 3? Okay, so how many people are done 4? Okay, I'm going to give you guys a couple more minutes before I do 3 and 4. If you're stuck on 3 and 4, remember that for 3 and 4, you need to also use Avogadro's number in an additional step, okay, that you didn't have to do in the first 2. All right, let's have a look at number 3 here. So we are now looking for the number of molecules. How many molecules? Okay, so number of molecules is our question mark. Okay, we're told it's sodium sulfide. So big M will be Na2S, properly swapped and dropped. So that'll be 22.99 plus, or sorry, times 2. Plus 32.07. All right. Yeah. Okay, so we're looking at 78.05 grams per mole. Okay. And they tell us the mass is 200 grams. Okay. If I want to find the number of molecules, I first need to know the number of moles, and that's what I can calculate with the 2 actual numbers I've been given here, molar mass and mass. So that's my next step. N equals little m over big M. So that'll be our 200 grams that we were given divided by the 78.05 grams per mole. Whoop, not 2200. Okay, so we are looking at 2.56 moles. So obviously I'm going to keep all those decimals. Okay, I'm not going to round, I'm just not going to write them all, but I'm going to leave them in my calculator. Right, I have 2.56 moles of this stuff. Okay, Avogadro's number, this one, 6.02 times 10 to the 23, is the number of molecules in a mole. So if I take this number, what do I need to do with this number and this number? I need to multiply them, right? Okay, this is the number in a mole. This is the number of moles. If I multiply them together, moles will cancel and I'll be left with the molecules. Okay, so that is our next step then. Okay, number of molecules equals N times Av's number, okay, which will be 2.56 with all the decimals that are in my calculator, times 6.02 times 10 to the 23. All right, so I'm going to take that number I just calculated with all the decimals, okay, and multiply it by Avogadro's number, 6.02 E23. Remember, guys, that E means times 10. If you put in an extra 10 there, you're always going to get a factor of 10 too big for your answer. All right, so if that's been happening to you, stop putting the 10 in there. Okay, it's just E23. All right. So I have 1.54 times 10 to the 24 molecules. Okay, so sorry, mark for givens, mark for this step, mark for that step, mark for the answer, 4-mark question. Any questions on number 3? Okay, how many people are done number 4? All right, let's have a look at 4. Okay, so in this one, they tell us the number of molecules and we're looking for mass. All right, so I know the number of molecules. Okay, it's 1.2 times 10 to the 25. Right, and I know the material, so I can calculate molar mass. This is iron 2 nitrate, so that's going to be Fe bracket NO3 and bracket 2, because this was the 2 plus and this is a minus 1, so when I drop and swap, that's what I need. All right, so we're going to have 55.85, that's the iron, okay, plus 14.01 times 2, because we have 2 nitrogens, plus 16 times 6, okay, because 3 times 2 is 6. So that'll give us our molar mass. Okay, so 163.87. Oh, I did? Oh, all right, I'll just add 16 onto that and then it'll be fixed. 179.87, better? Yeah, good catch. All right, so 179.87 grams per mole, right? Yeah, okay. I need to find mass. To get mass, I need number of moles and molar mass. So I've got molar mass, but I don't have number of moles. But I have the number of molecules, and I have Avogadro's number. This is the number of molecules in 1 mole. So if I know how many I have and how many are in 1 mole, what do I do with those 2 numbers to get the number of moles? Divide them, right? Okay, so N equals the number we have, 1.2 times 10 to the 25, divided by Avogadro's number, 6.02 times 10 to the 23. Same as us going 48 divided by 12 is 4 dozen. Okay, that's what we're doing here, right? We're calculating the number of moles. Okay, same way we calculate number of dozen. Okay, so we take our 1.2 to the 25. Whoop, wrong thing. Okay, 25, and we divide that by Avogadro's number. Okay, so we're looking at 19.93 moles. Again, you're going to keep all those decimals. I'm just not going to write them all. All All right, so now that I have N, now I can find M, because now I can use the mole equation. N equals little m over big M. Okay, I'm going to multiply both sides by M. Okay, so little m will equal, we had how many grams here? We had, oh, sorry, we're looking for grams. So we had how many moles? Right, 19.93. Okay, so we're going to have 19.93 times big M, which was 179.87. Yep. No. 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 Okay. If I have 48 donuts, how many dozen do I have? 4, right? So I divide 48 by 12. Okay, if I want to figure out the number of dozen. Moles are like a dozen. No, that's more, 10 to the 25. It's like several hundred times more. Yeah, and it's okay. This number could be smaller. If I have less than a mole, this number could be smaller, right? It could be 10 to the 18, and I would get a very small decimal for the number of moles. Does that make sense? Okay, so it's always number of molecules divided by molecules in a mole. That way the molecules cancel and I'm left with moles. Okay, so back to this here, we got our 19.93, okay, times 179.87. Okay, so we have 3,585.44 grams of this stuff. Okay, so 1 mark for the answer, 1 mark for your plugging in of numbers, 1 mark for your manipulation, 1 mark for calculating the number of moles, 1 mark for the givens. That's a 5-mark question. Okay, as we talked about yesterday, there's 1 of each on your unit exam. So it would be advisable for you to practice these before the unit exam, which is what you're going to do because that's what our plan is for today and tomorrow, is to practice mole calculations, okay, so that we know how to do them quickly and correctly for our unit exam on Thursday. All right, so now I have gone over the 4 ways that you can do a mole equation problem 4 times. Okay, so you have many examples in the podcast that you can rewatch if you need to, okay, if you're struggling with this stuff. But more importantly, you have me here in class today and tomorrow to ask if you're not getting the questions from the worksheet. Okay, so don't be afraid to ask. Okay, if there's something you don't get, ask. Okay, we got to know how to do this stuff. So, how far did you guys get on Friday on this one? Didn't get very far? Okay, so I've got question number 3 up here. I'll put the actual sheet up in just a second and you guys can work from that, or you can call it up on your phone, either way. Okay, but we need to be working on that one. Let's say, yeah, starting at question number 3. And we're going to just, we'll omit 4 and 6 for right now. Okay, so 3, 5, yeah, and we'll omit 7 as well. Okay, 3, 5, and 8, okay, for sure, and many of the ones past that also. Okay, so let's get to work on those. Number 7 is asking you whether you understand the difference between a element that is, or that comes as a single atom, and a molecular element. Okay, iron is not a molecular element. That means when I have a lump of iron, I have a whole bunch of single iron atoms. If I have a tank of oxygen, I have a whole bunch of oxygen molecules. So if I have 1 mole of oxygen gas, that is 6.02 times 10 to the 23 molecules of O2. That's actually 1.2 times 10 to the 24 atoms of oxygen, because it comes as a molecule. Okay, everybody follow me there? Okay, the mole thing always goes with the kind of the lowest form that thing comes in. Okay, oxygen gas comes as a molecule. So if I have 1 mole of oxygen gas, I actually have twice as many atoms as I would if I had 1 mole of iron. Okay, because iron comes as single atoms. Does everyone follow the difference there? Okay. Yes. So if I had a mole of phosphorus, I would have 4 times as many atoms as I would if I had a mole of iron. Yeah, because it comes as a molecule of 4 atoms. Okay. All right. So that's just that little thing. It's kind of confusing, but that's just understanding the difference between a molecule and an atom. All right. Any other ones we need to go over? Okay. So unit exam on Thursday. What do you need to bring with you? Calculator. Okay. You can't use your phone. Okay. It's going to be in the bin over there with your other technology. So real calculator needs to be scientific so you can use Avogadro's number. Pencil. Okay, you need to bring a pencil. You can bring a pen as well, but just make sure that your multiple choice is done in pencil. Okay, and bring your periodic table. I'm going to have a quick look at it before you write the test, just to make sure you haven't written too many things on it for yourself. Okay, if you have, then I'll give you a fresh periodic table at that point. So remember, those are the things you need to bring. Guys, if you come to class on Thursday without a calculator, okay, I only have 3. So if more than 3 of you come without a calculator, one of you is really out of luck. Okay? And that would be unfortunate because I wouldn't want to do the operations you have to do mathematically with long division, okay, on paper. That would really suck, right? And it's not like you can just say to your friend during a test, hey, can I borrow your calculator? Because then I'm going to go, what? What are you saying to each other over there? Are you cheating? I don't want that. Okay, so let's make sure we come to class prepared.